Okay, we are going to take notes on the distributive property and combining like terms. This is, like I said just a minute ago, this is the heart of algebra, the main thing. Now, don't try, those of you writing down, don't try to write down all the definitions, and we will work through the problems. I just lost my mouse. What do you need? No, I actually didn't say equations. I said write down expressions, because that's one of the words. That would be this part in the box over here. You don't need to write down the whole thing. And that was my first point, is these are not equations, because equations have to have equal signs. Yes. These are expressions. Those of you taking notes, just write down the part in the box, because the definitions are written down in the computer for you. These are expressions because they do not have equal signs. Expressions are made up of terms. This has different parts that are held together by adding and subtracting signs. So, this says x to the third power plus 2x squared minus 5x plus 4. Underline each term. These are the separate terms. This has 4 terms. You see them, 1, 2, 3, 4. This is 5xy minus 4x squared minus y. This one has 3 terms. If it has 3 terms, it's called a trinomial. We'll come back to those terms later, so don't try to write that down. 3 terms. This one has 1, 2, 3, 4 terms. The last one only has 1 term. It's called a monomial. And the terms are held together with adding and subtracting signs. Do we already know what the term variable means? What is it? It's the letters. The letters can be replaced with numbers. The variables are what separate arithmetic from algebra. I don't know how many times I've talked to students and they said, I did great in math, until they started putting those letters in there. The letters are, does that relate to any of you? The letters are variables and they represent numbers. These little numbers up here are exponents. We heard the word exponent before. This is x to the third power. Instead of writing x times x times x, I write x to the third power. The exponent means repeated multiplication. Now, I happen to have a highlighter with me. If you don't have a highlighter with you, you can go back and do this part. Are we familiar with the word coefficient? A lot of people have heard it before, and I realized I would start talking about coefficient and my students had no idea what I was talking about. These numbers that are in front of the variable, this 2x squared, the 2 is the coefficient. The negative 5 is the coefficient. The 5 in front of the xy is a coefficient. The negative 4 in front of the x squared is a coefficient. The 4 is a coefficient. The negative 2 is a coefficient. The 2 down here is a coefficient. Did you notice that when back up here at the top one, when I said the coefficient, I didn't say 5, I said negative 5? If there's a subtraction sign, it goes with the number. The coefficient is negative 5. This coefficient is positive 5. This coefficient is negative 4. Is this a coefficient? I thought a coefficient was a number. It's a number in front of a variable. Well, what do you call this one that doesn't have a variable? This number right here, our last term down there, this one is called a constant. If it doesn't have a variable, this is called a constant. This one right here would be a constant because it doesn't have a variable with it. Now, when we're writing our answers, the highest power should come first, and then a smaller power, and then a smaller power, and the constant should come last. That's just considered better form. Say again? The highlighted numbers right here, these numbers right here are called coefficients. These numbers in front of the variable are called coefficients. And before we can solve equations, we need to know how to combine like terms. So, those of you taking notes on your paper, write down combine like terms. That's the name of what we're going to do. Either way, combining like terms. So, first of all, we've got to know what a like term is. So here we have an expression. It's made up of terms, but it's not an equation because it doesn't have an equal sign. If it doesn't have an equal sign, you cannot solve it for x. Can't be solved. All I can do is combine it. Yes, so write down this expression. 3x squared minus 2x plus 1 plus 6x squared plus 3x. In order for it to be a like term, I've got to have the same variable with the same exponent. This one and this one and this one and this one all have x's, but they are not all like terms. This one and this one that have an x squared are like terms. And combine means you put them together. What's 3 plus 6? And this one and this one that both have an x, those are like terms. What do you get when you combine a negative 2 plus a 3? Now, some of you are not real great with adding and subtracting positive and negative numbers, and so I have put in Schoology under, it's not in a folder, I've put a PDF of integer rules, the rules for adding and subtracting positive and negative numbers. So, we have one number left. Do we have anything to combine with the 1? Now, this is an accurate answer, a correct answer, but it's not in good form. When we have 1x, that just represents 1x, so we usually just write down the x. So this would be a better form. When you have 3 positives and 2 negatives. Over here, 3x plus a negative 2x. When I combine those, what do I get? 1x. That's how I got this 1x right here. When the coefficient, back up here also, when the coefficient is not written, the coefficient is understood to be a 1. That's what combine means. That's the definition of combine. You put the things together that are alike. So, no. Okay, ladies and gentlemen, now we are going to look for like terms. And so here is a term that has an xy, and here's a term that has an xy. So if we add an xy and a minus xy, what's that going to equal? Isn't that going to cancel out? And so my xy's cancel out. Here I have y to the third power. Here I have a y to the third power. I have 4y to the third power and 6y to the third power. How many y to the third powers is 4 plus a 6? So this term and this term are like terms. Then down here at the end, I have this term right here. Is there anything like a y squared? No. So there's nothing to add to that. I just bring it down. The distributive property is when you have a number out in front of an adding or subtracting expression. X plus 8 is an expression with 2 terms, and I have the 3 out in front of it. Now, between the 3 and the parentheses, is there any adding or subtracting sign? No. So what that means is the 3 is multiplied by the parentheses. That means I have an x plus 8 and an x plus 8 and an x plus 8. How many x plus 8s did I write down? Because that's what the 3 out in front means. And so then I could add 1x plus another x plus another x. 1, 2, 3 x's. That's what the 3 out in front means I have 3 of those that are exactly the same. And I could add a 8 plus another 8 plus another 8. What's 8 plus 8 plus 8? That is what the meaning of the number out in front means. It means I have 3 of those and I need to add them up. But if I had 25 out in front of there, would I want to write out 25 of them and add them up? No. And repeated addition is the same thing as multiplication. So most of the time you will just see this with little arrows like that. What's 3 times x? And what's 3 times 8? Don't I get the same answer by just multiplying instead of writing it down and adding it up? And so that's what we do to shortcut having to write it all down and add it all up. So we multiply the number out in front by all of the parts. Question?
So if the 3 was the 3 parts of like 25 or something, it would be like 25 times x and then 25 times b.
Yes, and so let's go ahead and write down our next example. We have 5 times x minus 2. That means x minus 2 plus another x means that I'm going to take that x minus 2 and add 5 of them together. Now those of you writing it down, aren't you getting tired of writing down x plus 2's? So, instead of writing all those x plus 2's down and adding them up, we can multiply. What's 5 times an x? What's 5 times negative 2? And that's exactly the same thing you would get if you wrote it all down and added each one of those individually. And so the distributive property shortcuts this. Now, one of the trickiest kind of problems is when you have a negative sign out in front. A lot of people miss the negative sign out in front. So that's negative x plus 4. That's like negative 1 multiplied times x plus 4. So negative 1 times x is negative x. Negative 1 times 4, remember we have to multiply times both of those. That would be a negative 4. The other side. That's the expression multiplied out. That's not the other side of the equation. That's part of the simplify. Because do I have anything on the other side of this to make it an equation? No. This is multiplying and simplifying this expression. What do I get when I simplify this expression? What's negative 6 times x? What's 6 times 5? And negative times a positive makes a negative. Now, what if you have distributive property and combining like terms all in the same problem? What do you do first? Combining is adding. Distributing is multiplying. Do we remember from our order of operation which comes first? Adding or multiplying? So first, we distribute. So this would be 2 times 5 is 10x squared, and 2 times x is 2x. I didn't have anything to distribute here, so I just bring down that first expression. Now, I need to combine like terms.
Pardon this interruption. Students, if you have EDUC class or class has started and you need to go to the student union, please head to the student union if you are in EDUC. Thank you.
If that's you, please leave quietly. X squared and another x squared. Those are like terms because they both have x squared. What's 3 plus 10? This term and this term, why are they alike?
Because
They have x's. What's negative 2 and positive 2?
0.
So those zero out. And so what else do we have left here?
Plus 1.
So first you distribute and then you combine like terms.
So you got the 13x squared by adding, because 10x squared and 3x squared are the same.
They-
both have x squared.
They're like 10x squared and 3x squared are like terms, so we add them together, and that's where the 13 came from. Okay, one more example. Would you please write down it? Now, at first glance, this doesn't look like it has anything to distribute. But what's right here in the middle? And so before we add like terms, we need to distribute a -1. What's -1 times 10? And then it has the x squared. What's -1 times 4? And then we have the 4x squared plus 10x minus 2. Now I look for like terms. This has an x squared and this has an x squared. Now this may get tricky. This is a 4 and this is a -10. My integer rules say that when you have the same, oh no, I don't have same sign. I have different signs. You subtract them. What's 10 subtract 4? And then you take the sign that goes with the bigger number, the 10. And those integer rules are given for you in a PDF in Schoology. Okay, this one right here has an x without any power. Is that the only x without any power? Okay, and then we have this constant and this constant. Why do I call them constants? They don't have a variable, and this is a -2 and a -4. When they have the same sign, you add them up and you keep the sign. I would prefer you be able to add and subtract positive and negative numbers without a calculator, but some of you may need to use a calculator to help you out on those. And then you have an assignment on these types of problems. Now, how many days do you have to do for an assignment? 2. Is it best to wait till 11 o'clock on the second day? No, it's best to do the assignment as soon as you possibly can. That gives you a chance to maybe ask questions, and it's still fresh on your mind. If you wait 2 whole days, are you going to forget some of this? The purpose of the assignment is for you to learn how to do it, so do the assignment as soon as you can. But you do have 2 days before I'll check